Good morning, class. Today I want to talk about 6.3. So it's a trigonometric function with reference angles. Reference angle, so here's the definition of the reference angle. The measure of an angle, right, it's allocated right in between the terminal sides and the x-axis. So here's one of the random example. So let's say that we create the terminal side here. So the terminal side in the first quadrant. So let me just point in using the right arrow. Okay, so let's say we do have a terminal side right here. So that means the reference angle would be this one right here. Okay, so here's another example. So let's say we do have a terminal side in quadrant 2. So that means the reference angle, it's right in between the terminal side and the x-axis. Okay. So now, what about if the terminal side it's in quadrant 3? Okay, so let me just... So let's say we do have a terminal side in quadrant 3. So let's say that the terminal side is right here down the bottom. So that means the reference angles would be right in between the terminal side and the x-axis here. So now if the terminal side it's in quadrant 4 down here, again according to the definition, so this one is being bounded right between the x-axis and the terminal side. So the one that I drew right here, so those are just like 4 different scenarios showing that the way we find the reference angle or the reference number. Okay, so draw the following angle in standard positions and find the measure of the reference angle. So negative 150, so if just draw the angle here. So let's start out with the quadrant. So I need the x-axis and the y-axis. This one just the rate. Okay, so I can put in the arrow in a minute. Okay, so negative 150, so that means we're going by clockwise. So here we go, negative 150, so that's about over here. Well, because this one is 0, negative 90, negative 180, so negative 150, so we stop in quadrant 3. So now here's the reference angle. So I just want to use different color for this, or you want to color it. So the way to find it, so basically we just add 180. So negative 150 plus 180. Well, because the bounded angle is 180. So the reference angle would be considered 30. And keep that in mind. The reference angle is always considered positive, cannot be negative. Okay? So now, here's the next one. So 195 degree, 10 minutes. So for those you might be wondering, 10 minutes, is that part of the unit for the angle? It is. So I don't know whether some people learn this or not from geometry or trig. So the way to convert that degree to minute. So we do know that 1 degree, so that equals 16 minutes. And 1 minute, well, obviously 60 seconds. So minute, seconds, degree. And those are the units we use for measuring the angle. Okay, so 195 degree in 10 minutes. So let's just convert everything to degree first. So 195 plus 10 over 60 degrees. Okay, so 10 over 6, so that would be 1/6, so 195 and 1/6 degree. Okay, so you want to convert that, you want to find, well, let's just draw the standard position first. So we can find the reference angle. So once again, I need the x-axis, so let me pick the right arrow this time. Right there. So here's the x-axis, here's the y-axis. So 195 and 1/6, so that's it's going to pass through the 180 boundary. So slightly somewhere down there in quadrant 3. So it's 195 degree, well 195 and 1/6 degree. So the reference angle would be the one right between the x-axis and the terminal side. So the way to find this angle, So we just want to subtract 195 and 16 by 180. So once you subtract, so then you'll get 15 and 16. So we get 15 and 16 degrees. Okay, so that's pretty simple. And now, check it out the next slide here. See what else that we have. So now this one's getting a little bit more complicated. Find exact value for the following. So cosine of 225 degree. So we do know that reference angles of cosine of 225. So one thing that you want to do, you want to draw the diagram also for the standard position of 225 degrees. Again, 225, it's allocated in quadrant 3. And the reference angle will be the one that's right here. So let's find the reference angle first. So 225 minus 180. So 5 minus 0, 5. 12 minus 8, 4. So 45 degree. Now, another thing that I can do, you can always draw the line segment here. So let me just make this one better. So the line segment showing that it's a right triangle. So we do know that's a special ratio, 45, 45, 90. So what's cosine of 225? Again, cosine in quadrant 3, it's always considered negative. So the sign change in quadrant 3 is negative, negative. So the special right triangle, we do know that's 45, 45, 90. So the ratio for this one would be considered negative 1, root 2. So cosine of 225, so in other words, cosine of 45, which is negative ratio. So negative, well, cosine is adjacent over hypotenuse. So it's negative 1 over root 2, which is considered negative root 2 over 2. Again, this one is all about the special ratios of the 45, 45, 90 degree triangle. Again, anytime they see the ratios like that, it's always considered 1, 1, and root 2. The reason why it's being negative 1, because that it's in quadrant 3. See the x value here? To the left, it's always negative. Going down, it's negative. Hypotenuse, it's always positive, because that's the radius. So now, let's try another one. So 420. So 420, so that means the angle is going to pass through 360. So that means you have to go around the unit circle more than once. Okay, so go around the unit circle more than one. Okay, so let's just do this. More than once, so going back to the first quadrant. And here's the reference angle. So the way to find this, the reference angle, so it's 420 minus 360. So you get 60 degrees. So cotangent of 60 degree. So for the ratios of 30, 60, 90, so we do have 1, root 3, and 2. So cotangent of 60, which is considered adjacent over opposite. Okay, so adjacent over opposite. So this angle is 60, so opposite is root 3. Adjacent would be considered 1, and then over here is 2. So adjacent over opposite, then that would be considered 1 over root 3, which is root 3 over 3. Okay, so now what about for cosecant of 5, 10 degrees? So once again, draw the diagram. So to find out where the angle is located. So 5, 10, so we need to go around the unit circle once. 360 plus 90, we do have 450. Okay, so 450, we're almost getting there. Plus another 60. So That means it's going to be right here. So it's going to be allocated in quadrant 2. So 510, let's find the coterminal angle first. So 510 minus 360. So for that one, we do have 150. So basically this angle here, if you just go around the unit circle once, so this one is just 150. But now we need to find a reference angle. So 180 minus 150, which is 30. So the reference angle is 30. So for the ratio, we do have 1 negative root 3. And then over here is 2. Again, using the ratio, the one that we have for the special right triangle. Again, in quadrant 2, so it's considered negative, positive. So that's why the adjacent is considered negative here. So cosecant of 510, so cosecant, the ratio for that one is hypotenuse over opposite. So it's 2 over 1. Okay, so for the ratio, cosecant of 510, you just hypotenuse over opposite, 2 over 1, which is 2. So it's not that difficult, but the thing is that you need to recognize the unit circle with the special right triangle. And then the rest of this, you want to use that calculator to find out exactly what those are. So the way to put it into the calculator, there's no such button for secant. So you want to do this. So it's 1 over cosine of 311.7. And then you type in whatever that is on the calculator. Again, secant, which is the reciprocals of cosine. So you want to turn it into the ratio, the reciprocal form. And this one's similar, so there's no such thing for cosecant. On the calculator, you want to put in 1 over sine of 590.9. Again, whatever that is, just write it down. And then tangent is quite simple, so tangent of 171. Well, if that's asking for cotangent, so that means you want to take 1 over tangent of 171. Okay? Okay, so now let's see what else that we have for the rest of the slides here. So the next one, you want to find theta. If theta is right between 0 and 360, well, given that sine of theta is negative root 3 over 2. Okay, so this one's, okay, let me just rewrite it. So sine of theta, it's negative root 3 over 2. And where theta, it's in quadrant 2. Okay, well, it's supposed to be quadrant 3. This one, that's another one right here. Okay, so quadrant 3, so draw the diagram. So quadrant 3, bounded this way. So we do have sine of theta, so it's negative root 3 over 2, so negative root 3, opposite, hypotenuse 2, that means adjacent is negative 1. If you guys do remember this one is just one of those special right triangles. So this one is facing to the longer leg. If this angle is facing to the longer leg, that means the reference angle, it's considered 60 degrees. But the thing is that it's in quadrant 3, so 60 plus 180. So for theta, so this one would be considered 240 degrees. Okay? So now let's try another one. So tangent of theta, it's 1 over root 2. I think there's a typo for that one right there. Okay, let's see. Yeah, that's a little typo right there. That one's supposed to be tangent of theta equals 1 in quadrant 2. It's actually negative 1. So let me just rewrite the problem. This one's supposed to be negative 1 right here. So tangent, quadrant 2. So negative 1, so that's negative 1 over 1. Well, the things that opposite cannot be considered negative because that's in quadrant 2. So the negative, you can move that top to the bottom. So it can be written as 1 over negative 1. So it's 1 here, negative 1 here. Hypotenuse, root 2. So for those you might be wondering, the reference angle, that's right, it is 45 degrees. So that means theta, it's 180 minus 45 degrees. So it's 135 degrees. Okay. And then the rest of this, you want to use the calculator for this. Now, got to be careful with the ratio, the one that's given. Okay, let's try to do this one. Well, let me just demonstrate one of the problem here. So I need to pull out the Google calculator. Okay, so the one that's given is tangent of theta is 0.5890. Okay, so now one thing you need to watch out. This one is saying that theta, it's in quadrant 3. It's right here. So whatever the angle that we find out with the inverse of tangent of the ratio, that will only give you the reference angle. So once again, once we take the inverse of the ratios with tangent, the only angle that's given will be just considered a reference angle. So this one is not the actual angle of theta, it's just the reference angle. Okay, so now let's do it on the calculator and see what happens. So inverse of tangent of 0.589. So inverse of tangent of 0.589. So inverse tangent of 0.589. So the one that is given here, that's just a radians, so I want to convert that to degree. Okay, so let's try that one more time. Convert that to degree. So inverse of tangent, inverse tangent 0.589. So that one is about 30.498. So let's just round it up to one decimal place. So 30.5. Again, this one will just give you the reference angle. So 30.5. And we do know that it's in quadrant 3. So that means theta. So that one is going to be 30.5 plus 180, which is 210.5 degrees. Again, whatever the ratio that you find, that's just giving you the reference angle. So you got to be careful with that, the quadrant number. So whatever the quadrant number that you have, you need to subtract, or you need to add it with the boundary angle. So the next one is given that cotangent of theta. Okay, let me just rewrite this. Looks like it's being a little bit cut off there. So cotangent of theta, it's negative 0.1234. And theta, it's in quadrant 4. So let's take the ratios, inverse of ratios of cotangent of negative 0.1234. Now, for those you might be wondering, how do I put in the inverse of ratios of cotangent? So here's what you need to do. So it's cotangent inverse of this number. Well, that's just like a normal way to rewrite it. But the way that you want to put it into the calculator, it's inverse of tangent of the ratios of 1 over negative 0.1234. Because we do know that inverse of tangent, which is the reciprocals of cotangent, inverse of cotangent. So that's why we need to take the ratio as the reciprocal form. So let's do it on the calculator. Inverse of tangent. Inverse of tangent, parentheses, negative 0.1234. Okay, like that. And then hit enter. So that will give you the negative angle. It's negative 7.03. So negative, well, just put in negative 7. So negative 7, that means okay, well, let me just draw the diagram also. So it's quadrant, so negative 7, so that's just give you the reference angle. Now, as what I said earlier, so the reference angle is always positive, so you want to take the absolute value of that negative 7. So we got 7 here. And then, so theta, obviously is 360 minus 7. Because the boundary angle is 360 over here. So 360 minus 7, so you'll get 353 degrees. Okay? So got to be careful with the way that you find the angle. The one that we found, it's just a reference angle. Well, the reason why it's giving you -7 because that's going by clockwise. But the reference angle, it's always considered positive. So that's why I take the absolute value of -7. And then you subtract from 360. So you can get theta. Okay, so now let's see what else that we have for the rest of this. That's it. So this one is just part 1 of 6.3. Okay, so thank you for watching the video today.